Today we will discuss about the topic friction. So first of all, what is meant by friction? If two smooth surfaces are in the contact position, there will be no resistance to sliding. Sliding is nothing but motion between the two bodies. Instead of the two smooth surfaces, if we consider the rough bodies, then whenever that surfaces of the two rough bodies are in the contact position, there will be a limited amount of the resistance to sliding between them. So that resisting force, stopping force between the two bodies is nothing but a frictional force or friction. In one word we can say that resisting force which opposes the motion, that resisting force is nothing but a frictional force. And we can say that friction and motion always opposes to each other. Generally friction reduces the efficiency of the machines and results in the gradual wear of the material from the contacting surfaces. So friction and wear may be reduced by the lubrication process. Now coming to the classification, we have three types of the friction: solid, viscous and non-viscous type. Now what is mean by solid friction? If the friction between the two perfectly clean or dry or unlubricated solid surfaces, then that type of a friction is known as solid or dry friction. And under this solid or dry friction, again we have two types of static friction and dynamic friction. And we all know that static means rest position and dynamic means moving position. So if two surfaces are in the rest position, then the friction between the two rough surfaces is known as static friction. And if one surface is in the rest position and one surface is in the moving position, then the friction between them is nothing but a dynamic friction. And in the dynamic friction, in the moving process, at the point of the sliding, the friction between the two contacting surfaces is known as limiting friction, and we will use that limiting friction concept in the coefficient of the friction topic. Now coming to the second type, viscous or fluid. Generally if two surfaces are separated completely by a thick film of the lubricant type of the things, then the friction between the two surfaces is known as the viscous or fluid. Once again, if the two surfaces are completely separated by a thick film of the lubricant, if we use a thick film of the lubricant, then the friction between the two surfaces is known as viscous or fluid. Instead of the thick film of the lubricant, if we use a very extremely thin layer of a oil type of the lubricants, then that type of the friction is known as non-viscous or greasy friction. Now coming to the coefficient of the friction. Coefficient of the friction is the ratio of limiting force of the friction to the normal reaction between the two bodies. So that ratio of F by R is nothing but coefficient of the friction. F is nothing but limiting frictional force. R is nothing but normal reaction. When two bodies are in the contact position, one force will act on the another body. So that reaction between the two bodies is nothing but a normal reaction which acts in the perpendicular direction. So that R is nothing but normal reaction. So limiting frictional force and a normal reaction force ratio is nothing but coefficient of the friction. That is denoted by mu symbol. So mu is equal to F by R. From this one we can get F is equal to mu R. This is the first formula and basic formula in all the problems in the friction topic. Now coming to the angle of the friction. Here if we consider any body which is in the equilibrium position, then we will get this type of the diagram. Here we are applying a force P towards the positive x direction, and we know that motion and friction always opposes to each other. When we are applying P force towards the positive x direction, means motion is also towards the positive x direction. So we will get the frictional force towards the negative x direction, and for any body weight will act in the downward direction, and normal reaction here which is acting in the upward direction. So this body is in the equilibrium condition, and here R1 is the resultant force of R and F. So angle between normal reaction and resultant force of normal reaction and frictional force, that angle is nothing but angle of the friction. In one word we can say that angle between R1 and R, resultant force and a normal reaction, that angle is nothing but angle of the friction, and it is denoted by phi. Now from this diagram, here you will get one right angle triangle. Here one right angle triangle. So from the right angle triangle, if we take tan phi is equal to opposite side by adjacent side, so f by r, and we know that f is equal to mu r from the concept of the mu. So f is equal to mu r by r, you will get the mu value. So phi is equal to tan inverse of mu. So this is the second formula. Once again, we know that motion and friction always opposes to each other. Next, in the classification we have three types. Next, from the concept of the coefficient of the friction, we are getting the first formula, f is equal to mu r. Next, from the angle of the friction, you are getting the second formula, phi is equal to tan inverse of mu. These are the basic things we need to follow to solve the problems of the friction topic. Now coming to the so many combinations of the equilibrium conditions of the bodies in the friction topic. Generally we have two types: equilibrium of a body on a rough horizontal plane and equilibrium of a body on a rough inclined plane. Now coming to the first type, when body is on the rough horizontal plane, and if we take the equilibrium condition of that particular body, this is the diagram. Like here we are applying the P force towards the positive x-axis, so motion will be towards the positive x-axis only. So you will get the frictional force towards the negative x direction, and weight in the downward direction and R in the upward direction. So this is the general reaction forces you will get for this body, which is in the equilibrium condition when it is on a rough horizontal plane. This is the rough horizontal plane. Now under this type of the combination, whenever a force is applied on it, that body will tend to move in the direction of that force only. So you will get the basic formula from the friction topic as f is equal to mu r. So this is the only formula you have to use whenever you get a problem which is related to equilibrium of a body on a rough horizontal plane. Now coming to the second type, equilibrium of a body on a rough inclined plane. Inclined plane means horizontal plane will be having some inclination alpha value to the horizontal plane. So here this is the horizontal plane, and here alpha is nothing but angle of inclination, this is nothing but a inclined plane. So here we are considering a body on a rough inclined plane, and here alpha is nothing but angle of inclination. Now here again in this type we have two types. Here in these types we will compare the angles alpha and phi. Alpha is the angle of the inclination and phi is the angle of the friction. When you compare both these angles, when alpha is less than phi, then this body will be automatically in the equilibrium condition. No need of doing anything for that particular body. It will be in the equilibrium condition only. So no need of any extra force addition or nothing to do. So this will be the original diagram, and this will be in that position only when alpha is less than phi. Suppose for example, if alpha is greater than phi, here inclination is very larger value, then this body will not be in the equilibrium condition. It will tend to move in the downward direction, it will tend to slide in the downward direction. So it is not in the equilibrium condition. So we need to get back that body into the equilibrium condition by adding this extra force, external force P force in the upward direction. So here in this type you will get one extra force P force. By that addition of that P force, we can get back that body into the equilibrium condition. That body will be in the equilibrium condition after addition of that P force. Again in this type, again we have three types according to this P force. There are many types of the forces for the movement of that particular body, like force acting along the inclined plane, force acting horizontally, and force acting at some angle with the inclined plane. In these three types also, again we will get two types, like at the point of the sliding in the downward direction and at the point of the sliding in the upward direction. So these are the so many types in the combinations. Once again here, this is the first type, equilibrium of a body on a rough horizontal plane. Second type is equilibrium of a body on a rough inclined plane. In this type we have again two types. If alpha is less than phi, that body will be in the equilibrium condition. If alpha is greater than phi, it will not be in the equilibrium condition, we need to get back the body into the equilibrium condition by adding this P force in the upward direction. So this P is again of three types, like these three types. So these are the different types of equilibrium of a body on a horizontal plane or inclined plane, and comparison to the alpha and the phi. Now we will see these three types. Now first type is nothing but first type is force acting along the inclined plane. Here observe both the diagrams here. Here P is acting, here P1 and here P2. Here P1 is acting along the inclined plane. Here P2 is acting along the inclined plane. So these are the two types of the first type. Now here again first type is body at the point of the sliding in the downward direction. Sliding in the downward direction means motion is in the downward direction. We know that motion and friction always opposes to each other. Here at the point of sliding in the downward direction, we will get the frictional resistance force in the upward direction. See the arrow mark here. So in this combination, for this diagram, if you apply all the equilibrium conditions like sigma h is equal to 0 and sigma v is equal to 0, you will get this P1 value as in this formula. Here P1 is nothing but the minimum force. Minimum force is nothing but which will keep this body in the equilibrium condition when it is in the when it is at the point of in the sliding downward direction. So here P1 is the minimum force which will keep this body in the equilibrium condition. Now at the point of sliding in the upward direction means motion is in the upward direction. Then frictional resistance force will act in the downward direction. So for this diagram, if you apply again equilibrium condition sigma h and sigma v is equal to 0, you will get this formula for the P2 value. So P2 is nothing but maximum force which will keep this body in the equilibrium condition at the point of the sliding in the upward direction. Once again, this is the first type. First type in the second type of the equilibrium conditions. Second type equilibrium condition is nothing but equilibrium of a body on a rough inclined plane. In that one, first type means force which is acting along the inclined plane, first type. In that first type, we have again two types. At the point of the sliding downward direction, at the point of sliding in the upward direction. In these two types, you will get these two formulas. P1 is the minimum force, P2 is the maximum force. Next, coming to the second type. Second type is nothing but where force is acting horizontally. Here observe these two diagrams and this diagram. Here P1 and P2 are acting along the inclined plane. Here P1 and P2 in the next paper will act along horizontally to the horizontal plane. So here P1 is acting horizontally to the horizontal plane, and here sliding in the downward direction condition means motion will be in the downward direction. So you will get the frictional resistance force in the upward direction. Again for this one, if you apply the equilibrium conditions, you will get this P1 formula. P1 is nothing but a minimum force. Now again for the second type means sliding in the upward direction. Sliding in the upward direction means motion is in the upward direction. So you will get the frictional resistance force in the downward direction. Again for this one, if you apply sigma h and sigma v is equal to 0, you will get this P2 formula. P2 is nothing but maximum force. So these are the two types in the second type of the force. Now coming to the last type, third type. Third type is nothing but force acting at some angle with the inclined plane. Here observe the theta value. Here P1 and P2. P1 and P2 is the force which is acting with some angle theta to the inclined plane. Observe this diagram and this diagram. Here P2 is acting horizontally to the horizontal plane. Here P1 is acting with some inclination to the inclined plane. So again here for these two diagrams, you will get the same explanation. Here sliding in the downward direction, motion is in the downward direction. So frictional resistance force will act in the upward direction. Here motion is in the upward direction. So you will get the frictional resistance force in the downward direction. For these two diagrams, if you apply the equilibrium conditions, you will get these two formulas. P1 is the minimum force and P2 is the maximum force. Once again observe all the diagrams. Here first type, force is acting along the inclined plane. P1 and P2 are acting along the inclined plane. These are the two formulas. Here P1 is acting horizontally to the horizontal plane. P1 formula. Here P2 acting horizontally to the horizontal plane. P2 formula. Last third type. Here P1 and P2 acting with some angle to the inclined plane. Acting with some angle to the inclined plane. These are the two formulas, P1 and P2. Now generally in any problem in the friction topic, you may get individually one of the types in these combinations. You can directly apply the formula, or if you don't remember the formula also, for that particular problem, if you apply sigma h and sigma v is equal to 0, you can solve the problem according to the first unit, like resolution part and RCF diagram, rectangular components force diagram, and from that if you apply the equilibrium conditions, you can solve the problem. If you remember these formulas, you can apply the formula directly. If you don't remember these formulas, you can solve according to the equilibrium conditions. And one more thing, you may get the problems in the combinations also, like first diagram, first type combination, in that again first type with the second type first type combination, or second type in the first type, and with the combination of first type in the third type. Like you may get the combinations of all these topics also. So in that way also, if you remember the formula, it will be easy for you. If you don't remember the formula also, it will be easy only. And you know that equilibrium conditions, every body will be in the equilibrium condition. So by applying that equilibrium conditions, compulsory that diagram should satisfy the equilibrium conditions. So if you apply the equilibrium conditions like sigma h and sigma v is equal to 0, you will get the problem. If you do the problem by the formula method or equilibrium conditions method, you will get the same answer only. So in the friction topic, you will get the problems based on these combinations.